Hi everyone. All right. Last topic of the year, I believe. And we had been solving exponential equations. We're going to go to logarithmic equations. And there might be some that we can do one to one, but there might be others where it might help us just to be able to convert a logarithmic equation to an exponential. So let's just look at some examples and see what happens here. My first example, let's just start pretty basic. Log base 6 of x equals 3. Log base 6 of what number would equal 3? So I think the thing to do here is convert this to an exponential. And 6 is the base, 3 is the exponent, and that would equal x when we rewrite that. And 6 to the third power is 216. So x is equal to 216. And if you wanted to check, this is my log base calculators. Whoops, clear that. So let's hit math. Go down to log base. And let's take the log base 6 of 216. And lo and behold, that is 3. I know it's kind of in that dark spot, but that does say 3. So x is 216. Now my second example. Natural log of x is equal to 2/3. And this is another one. I think I just want to do what I did up here. Now remember, this is log base e. So I'm going to take e to the 2/3 power, and that should equal my x when I rewrite this as a exponential equation. So second, and then e, that's the second, and then the natural log button is the one I hit here. And then I'll just raise that to the 2 divided by 3 power. I get 1.945. X is approximately 1.945. And if I check that, I'm going to go E. No, that's not what I'm checking. I want to take the natural log. I want to take the natural log of 1.945, and I'm getting 0.665. Remember, 2/3 is 0.6 repeating, so I think that's pretty close. All right, so we'll stick with that one. Now, third example. Let me take log base 2 of 2x minus 3 equals log base 2 of x plus 4. Now, I'm not going to change this to an exponential. This is a one-to-one correspondence. These operations are the same. So I'm going to take those out and say 2x minus 3 equals x plus 4. So, let's subtract x. I got x minus 3 equals 4, and I'll add 3 and get x is 7. So 2 times 7, 14. Log base 2 of 11. 7 plus 4 equals log base 2 of 11. I think we're good there. All right. Well, let's look at another example. My fourth example. And I got the log of 4x minus the log of 12 plus x equals the log of 2. All right, I'm going to use a property here. Try to get this into one log. And then see what, and as one of our classmates would say, let's hope for the best. We'll use some properties and hope for the best. But this time, I'm going to take Alright, I'm hearing a lot of excess noise from my family right now, but we'll get through this. So I'm going to take the log and use the quotient property of 4x over 12 plus x equals the log of 2. And now I got another, those are the same operations, a one-to-one correspondence here between these two sides. So I'm going to just take that out and just go 4x over 12 plus x equals 2. And I'll multiply this side by 12 plus x. And I'll multiply this side by 12 plus x. Get those cancel out. I got 4x equals 24 plus 2x when I distribute. And if I subtract 2x, I'm looking at 2x equals 24 and x equals 12. Alright, so 4 times 12 is 48. 12 plus 12 is 24. So I'm just going to check real quick here. The log of 48 minus the log, whoops, okay, I need to put parentheses here, minus, whoa, that's not going to like it if I leave that there, minus the log of 24. 12 plus 12 is 24. Alright, that's what that equals. Now what's the log of 2 equal? Hopefully the same thing. Hey, looky there. Okay, those match up. So x does equal 12. Alright, when we go through and check. Let's look at, what number am I on here? Example 5. Let's take the log. Let's actually not do that. Let's take 7 plus 3 times the natural log of x. That's ln, not, that almost looks like limit with me. Okay, I'm going to subtract 7. And I got 3 times the natural log of x equals negative 2. That's a 3. 3 times the natural log of x equals 2, negative 2. Divide by 3. The natural log of x equals negative 2/3. Alright, I think this is one where I might want to rewrite this in exponential form. And this is log base e. Base e. The exponent is negative 2/3, and that equals x. So e, second, e. Power is negative 2/3. 0.513. That's approximately what x is. Well, I'm curious. I'm going to check. 7 plus 3 times the natural log of 0.513 equals 4.9975. Okay, really close to 5. Something really close to 5. Which was rounded. Okay. I got 2 more examples. I'm gonna power through these. Sometimes I like to shorten it because it takes a long time to upload, but I'm gonna just go through it. Example 6. 3 times the log base 4 of 6x equals 9. Alright, let's get the log solved for. Log base 4 of 6x is equal to 3. Now, I am going to rewrite this. I think it would be, the thing to do here would rewrite it as an exponential. Base 4 the power is 3, and that's equal to 6x. And if I divide by 6 and divide by 6, I get x here. So 4 to the third power divided by 6, 10.66. I'm gonna guess that is 2/3. 10 and 2/3, not 10 to the power of 2/3. It's 10. It's a mixed number. 10 and 2/3. Okay. If I multiply that by 6, I get 64. So if I take 3 log base 4 of 64. That's 9, and that's what we were hoping for, 9. So x is 10 and 2/3 there. All right, my last example, I'll just ignore that heading there. I'm still doing that. Last example of the year with my beloved students here. Example 7. Yes. I'm going to take the log of x plus the log of x minus 9, and that is equal to 1. All right, now this is plus here. So I'm going to combine, I'm going to condense that. Now plus, that goes, if I go in reverse, that goes with the product property. So I'm going to take x times x minus 9 and make that into one logarithm there. And then I have the log of x squared minus 9x equals 1. Okay, now I'm going to rewrite this as this is a base 10. So 10 to the first power equals x squared minus 9x. And let's just rewrite this. X squared minus 9x equals 10. Let me subtract 10 from both sides and get x squared minus 9x minus 10 equals 0. Okay, let's do some factoring. Minus 10 plus 1. X minus 10 equals 0, or x plus 1 equals 0. X equals 10, or x equals negative 1. It is time to check. Log of 10, that's 1. Log base 10 of 10 to the first power, that's 1. Plus the log of 1. The log of 1 is 0. I think you've seen that. It says 1. So x does equal 10. Let's look at negative 1. The log of negative 1. I think we know what's going to happen here. Can't do it. Okay, that's just something that's undefined, so you do need to check. Just don't assume both of them work. Negative 1 is an extraneous solution, so x equals 10 is the lone solution there. All right, guys, it has been truly a pleasure. I have been blessed to have crossed paths with you guys. Teaching is very fulfilling when I have people like you in my life to do it to. So, God bless you. I hope you have a wonderful summer. You do have a test, but I hope you have a wonderful and pray for me, as you can hear. And when we see each other again, please stop by and say hello, because I really look forward to seeing you all again. All right. God bless you. Bye-bye.